Let's solve this example. And this is example 1 on page 245. Solve this system graphically. So there are two equations. Y minus x equal 1, y plus x equal to 3. And by now, I hope you all know how to graph a line. We practiced this earlier in the earliest section, I think 2.1. So we know how to graph it. Y minus x equal 1. This is the first line, okay? Now, to make space, let's start here. When graphing a line, I like to solve this linear equation to y equal something, okay? Y equal to y on one side, the rest on the right hand side. I can solve for y by adding x on both sides, okay? Y, there's no y, I mean y is plus 0 is y. Negative x plus x is 0. 1, there's no 1 here, means 0. So 1 plus 0 is 1. X plus nothing up here, so x plus 0x is x. Simplify, you have y equal to 1 plus x. Okay? So this is a step to obtain y equal 1 plus x. So let me rewriting this here. Okay, and I'll do this part. For the second line, I have y plus x equal to 3. Same procedure. I like to convert this to y equal to something. So y on the left hand side. The remaining terms, move it to the right hand side. To solve for y, we need to remove the x. So I'll subtract x on both hand side. On both sides. So y plus 0 is y. X and subtract x is 0. 3 subtract x is 3 subtract x. Okay? So simplify, we have y equal to 3 negative x. Rewriting this here, we have y equal to 3 negative x. Okay? Let me make space, remove this. So we have these two equations. You can draw two tables. This table for the first equation, 1 plus x. The second table for the second equation, 3 minus x. Okay. And remember to draw a line, all you need 2 points. Okay. Third point is for checking. So let me start with, you can pick any number you want, but pick easy number like 0, 1, okay, 0, 1. When x goes 0, okay, x goes 0, 1 plus 0 is 1. So y equal 1, okay. Substitute x equals 0 for x here. 1 plus 0 is 1, so y equal 1. Substitute 1 here, 2x. So 1 plus 1, right, is 2. So y equal 2. And here, you can find one more point, okay? For a quiz, for test, make sure you do it. Just to make sure you check your work. But I'm pretty sure it's correct. So for now, I'm just follow the way to at least 2 points. So when x equals 0, you plug it here. 3 subtract 0 is 3. 1, x is 1, substitute here, you get 3 subtract 1 is 2. Okay, so let's graph it. When x equals 0, y equals 1. So x equals 0, y 1 is here. So this point right here, 0, 1. When x is 1, y is 2. Somewhere here. Okay. So if you have 2 points, that means you can draw a line. The first one, let me draw it, go through the 2 points somewhere here. Now let's draw the second line. This time, let me use the green color. and let me label y equal to 1 plus x, okay? For this second line right here, when x equals 0, y equals 3. So up here, x equals 0, y equals 3. When x equals 1, let me label it 0, 3. When x equals 1, y equals 2, x equals 1, y equals 2. It's right here. So it's also 1, 2, okay? Right here. So if you know these 2 points, you can connect them. Okay? So this is the equation for the second line, y equal to 3 minus x, okay? And the line extend infinitely, that arrow here. Same thing for the other line. Now, the question is solve this system graphically. So we just graph these 2 lines, okay? Now, we're not done yet. We just graph it. So the question is solve this system equation. Remember, when you solve it, there are 3 possible cases. Either you'll get the solution as this case, or this case, this case. Now, which case is that? Case 1, case 2, case 3, which one? These 2 lines intersect at 1 point, right? So it got to be case 1. So you would say that solve, right? So you say the answer or the solution is 1, 2. Okay, the solution is 1, 2. Now on the quiz, I would ask you another question, mean how about this system? Is it consistent or inconsistent? Now, so in this case, it has at least it has 1 solution, right? And if you look at the definition of consistent system and inconsistent system, the first line is saying that if a system of equation has at least 1 solution, meaning 1 solution or more, that means it's consistent. So you say the system is consistent. Okay, it's consistent because it has 1 solution. And I will ask you, is the system dependent or independent? And you can find that from the definition. For this case, because there are different lines, right? If there are different lines, what does it mean? And you look at the definition and say that the graph of equation are the same line. This is not the same line, so you've got to read the last one, would say the graphs of equations are different lines, right? They're different. Then the graph are independent. So you say the system is independent. Okay? So the solution is 1, 2. The system is consistent because it has 1 solution. The system is independent because these 2 lines are different lines.